All right. One more. There she is. Okay. Everybody is here. Very good, very good. That means we can put that there. That goes there. And we can get started. All right. Good morning, everybody. Hello, hello. It is time to dive into the conic sections themselves. Remember last week, distance and midpoint, that was a setup, okay? Now we get to see what these actual conic sections are like. And we're going to go through each one in turn. We've got the parabolas today. We've got the cycles tomorrow. We've got the ellipses after that. And then next week, the final guy, the weird one out, the hyperbola. Or hyperbola, if you prefer. All right, but let's narrow it back down. Hold on. Parabolas. And I know what you're saying, Mr. Apple. Didn't we do parabolas? Isn't that the graph of just a quadratic equation? We did those last semester. Yes, but we were missing one very important point. Specifically, a point on the graph called the focus of the parabola, right? I hear that there is such a curve out there that takes incoming rays and redirects them all to a single point. That is a parabolic curve, right? Thus, if you wanted to build a death ray, because you're a mad scientist, or you just made poor choices in life and have lots of enemies that need frying, right? You could construct a parabolic mirror, and all of the rays of the sun coming in get bounced and reflected, focused in on that single point. They all redirect there. Sunlight itself, fairly diffuse, not much of a problem. It doesn't burn things, right? But if you ever gotten a magnifying glass and fried ants on the sidewalk, or seen that done, or seen Toy Story, right? You'll see that they can be focused, and they can start fires. In fact. And so it doesn't take that large of a mirror to gather enough sunlight directed at a single point. You can actually cause at least pretty flammable stuff. You can cause them to combust, all right? And I had a video, I don't remember what I attached it to. Yeah, on the master schedule. So here's a teaser for why you should be always looking at the master schedule. There is a link to a very cool video about building your very own parabolic mirror for fiery fun. Okay? I'll just leave that there for you to peruse on your own time. But we want to know, okay, so how can we do this? We know it's got to be a parabola of some sort. How do we know what kind of parabola? How big? How small? Is it wide parabola? Tall, skinny parabola? What version of parabola are we dealing with here? How do we know? What does this number come from? If, say, we want to hit something 10 meters away, just for example, right? Find the equation of, in this case, a sideways parabola. We're not going to hold it underneath the guy or above, right? We've got to go from the side. Okay, so we're just going to switch x and y. Don't worry about that. The usual x's and y's will be swapped. But with a focus 10 meters from the vertex. Hey, vertex, that's something we know about. We already know how to find the vertex of a parabola. Can we go one step further? And that is what you read about this weekend, is more about parabolas. And they have this new fancy feature, right, called the focus and a directrix. And this is where the distance formula came in, because a parabola can be created with all the points that are the same distance from a point and a line. Oh, now it's not just from one point to another point. It's from one point and a line. Okay, so notice right down here at the vertex itself, it is equidistant from the focus straight up, the directrix straight down. But if I go over to the side, right, well, now it's this diagonal thing versus straight down to the directrix. Okay, and the parabola is all of those points. As I go out to the side, how much further up do I have to go, so that as far away as I go from here, I am the same distance from there. Okay? That's pretty neat. And that is the point where all of our light rays coming in will bounce off into the focus and fry our enemies. All right? So the first thing that the book has us do is taking a look at those equations of a parabola. They refer to this as standard form now. Well, it's not the general form, it's not the polynomial form, but we know it already as the vertex form, right? Because this is the version that shows us where the vertex is right in the equation. It's those numbers right there. X plus 4, whole thing plus 2, so we're at negative 4 comma 2. Right? There's our vertex. Oops, give me a pen. Right out of the equation. Now, how do you go from one to the other? This is where completing the square, I feel, comes in the most handy. As a tool for solving a quadratic, it works, but so does the quadratic formula, so you might as well use that, right? But here's where it really shines, is in converting from one version of the equation to another. We want to construct this as if we could factor it. Okay, so we want to group the x's together. I would like to GCF out that 3 there, keep it nice and simple for me. And then from within here, what do I have to add to make this a perfect square? Turns out 16, right? Half of the b term, take half of 8, that's 4, square that gives us our number. And if we add that, we also have to subtract it. Okay, so notice we've got plus and minus there, but we didn't just add 16. 16 was inside the parentheses, so it's actually being multiplied by 3. So 3 times 16. That's why we have minus 3 times 16 again. Very nice setup. And so you go ahead and reduce those constants. Do factorize this into its binomial form, and that gets us our vertex form of the parabola. Okay? Now what? Now what do we do with that? That's all well and good, but that's only the first step. How does that relate to the focus? Well, here then are all of the distances, and we get this cool new word, the lattice rectum. Yep, we said that. The parabola has a lattice rectum, and we're going to measure it. I don't know why they did that. I don't know. Blame the, actually I believe it's Latin in this case. So the Romans, okay? It's all their fault, okay? Anyways, back to the parabola. So we've got a focus up here. Somewhere in the middle, we've got a vertex down here, vertex at h comma k. Okay? And when it's in vertex form, when the equation is in vertex form, we can easily read that. And we just want to know, what is this length up here? Because this lattice rectum does a good job of defining how wide the parabola is based on its distance from the focus, right? This is all connected. That length from vertex to focus, I have labeled L here, sometimes called the focal length. You take that distance and double it sideways, you will get back to the parabola itself. We have 2L on this side, plus another 2L on that side, so you've got 4 L's all the way across. Okay? The focal length versus, you could almost think of this as the focal width. It's just how wide is the parabola at the focal depth. That's all it's comparing there. And it's always going to be 4 times as wide as the focal depth, or focal length. And it turns out that distance is always the reciprocal of your leading coefficient A. 1 over A is the length of the lattice rectum. The focal length is 1/4 of that. So we go down here to this handy-dandy chart. If in your notes of the weekend you did not put down this whole box, please go back and do so. This concept summary is like the book blinking lights neon sign, hey, write this down. This is the best piece of notes you can have. Okay? So we've got the focus here, and it gives us our specific location. If the vertex is at h comma k, then the focus is at h comma k plus 1 over 4a, because this 1 over 4a is our focal length. Now, I think we've done enough with parabolas so far, right? We understand how to find the vertex, especially if it's in vertex form. We understand how to find the axis of symmetry. We've already practiced that last semester. More than enough. The directrix, again, is part of that defining. Well, the parabola is points that are the same distance from focus and directrix. So the directrix, its only role is to be a line from which the distances are the same. But notice, it's at the same place. Use that 1 over 4a. If the focus is above the vertex, the directrix is the same distance below the vertex. They go hand in hand. And so all we really need to know is that 1 over 4a. 1 over 4a. This is the key new value to remember. Focal length, 1 over 4a. Focal length, all right? Commit that little bit to memory. And you can now find the focus, you can find the directrix, you could find the length of the lattice rectum if asked. Just take that and multiply it back by 4 again. Right? Any of those things stem from this. So this is the only formulaic bit you got to remember. And if you have that plus this image in your head, how these things all relate to each other, you're set. Okay? That's general enough. That's just enough information that you can always piece together. Now, if you want to go one step further and have more of this table in your mind, that will just help you answer questions faster. Okay? Instead of having to rederive everything, you can think of these as the shortcut answers. Okay, notice the difference here versus a parabola opening up or down versus left or right. It's just a matter of where you apply things to either the y value or the x term. It's all right there. So can we use that to work backwards to develop our death ray, right? I know my focal length now. Is equal to, I want it to be 10 meters. Okay? So if that is equal to 1 over 4a, let's solve for a. All right, so we're going to take both sides, multiply by 4. 40 meters is 1 over a. And now I need to multiply both sides by a. A times 40 equals 1. So then a divide both sides by 40 is 1 over 40. 1/40th of a meter. One-fourth would be 0.25. This is a tenth of that, so 0.025 meters. So that gives me part of my equation. My equation would be y, well, no, not y equals. Remember, it's a sideways parabola. X equals 0.025 times y minus plus h. And we got to swap h and k as well, because k goes with the y value. Where do we want to put our vertex? It doesn't matter, right? This is all relativistic, right? Let's make it easier on ourselves. If you're going to build this, if you're going to model this thing, let's say you really want to construct this. We're like, okay, I'm going to create a 3D model in the computer and then 3D print it. Okay, nice, hard, solid plastic, and then we'll coat the inside with the reflective material, and there you go, right? Instant giant parabolic mirror. Okay, do that. Well, then make it easier on yourself. Put the vertex at 0, 0, right? Why don't we just set the vertex to be 0, 0, and then our equation becomes 0.025 y squared. There you go. There's your equation. Put that in your CAD program and start printing out a giant death ray. Of course, you have to determine how much of the parabola you want. That could be an extension question, right? If this is 10 meters from the vertex to here, right, is how far? Right, call that some distance. We'll use B because A is already used. Right? You go the full length, right? Your lattice rectum, your parabola would stretch way down here, and it would be bigger than the guy is. You'd have to try to entrap him in this giant dome rather than just using a little dish to reflect it, right? You get a lot more sun that way. So some things to consider. All right, any questions so far on parabolas? Now with more focus. Try to give you guys something a little bit different than just here's go through the examples from the textbook, because you read that part. Right? I don't need to go over the same examples again. Let's give it something different. Because that means I haven't hit on every single piece of information. Any questions remaining? Anything unclear from this section? How to get it into vertex form? I think once you've got that, how to get the rest of these, again, axis symmetry and the vertex itself, either read straight from the equation, we've done it before. Get that focal length. Add that to your vertex to get your focus. Subtract it to get your directrix, or subtract to get the focus and add to directrix. It depends on which way it's opening, which is dependent on is A positive or negative, right? If A was negative, well then this would be 1 over 4A. Well, A is already a negative number, right? So this will automatically turn into subtraction. So keep the sign with A, and you won't have to worry about that problem. No questions? Anyone want to see another example? Or are you ready for the quizzes?
I think another example would be helpful.
I'm sorry, say that again.
I think another example would be helpful.
Another example? All right. Let's do this one. I've got 5 already done here. Let's do 6 then. We'll clear this out. Yeah, this will be faster. There we go. Clear that out. Let's do number 6. Back to blue here. All right, we want to identify the coordinates of the vertex and focus. Of course, the equation of the axis of symmetry and directrix, direction of opening, and length of the lattice rectum. And it says graph. I'm going to say we'll just produce a quick sketch. You, of course, have the graphing calculator, so you can easily get a very accurate graph to compare to from there. But our computation-wise, oh, wait, you know what? Let's not do 6. 6 is already in vertex form. That's too easy. Let's do 7. There it's in the general form, the polynomial form. So let's practice our complete the square here. So first up, can we want to factor out that 3. We want to get down to something like that. So negative 3 comes out, we get x squared. This becomes positive 8/3 x. Well, it ends up being a fraction. That's a little unfortunate. But honestly, I would rather just deal with the fraction right here than to try to like not factor this out and have to bring it back in later. We'll just treat it there, right? Fractions are your friends too. Okay, just because they look funny doesn't mean you should be making fun of them. And we will complete the square by adding some more. Leave the minus 6. Whatever we add there, we also want to subtract. And I like the way the book did that before. Instead of 1 blank, let's just go ahead and put times negative 3. Ooh, that's going to make it a plus, right? Put the negative 3 times our blank. That way our blank is the same number, and we already have the multiplied by negative 3 to compensate. Okay, so in this case, we're adding that amount because this gets subtracted. So what is that amount going to be? We take the 8/3, we divide it by 2, we get 4/3, square that, 16/9. Add to both places. And now we can reduce. This is now negative 3 times x. This is all plus the 4/3. So that becomes our number in there. Minus 6 plus 3 times 16/9. Ooh, what is this going to be? Well, 9 divides by 3, so that comes down to just 3. So it's negative 6 plus 16/3. All right, how many thirds is 6? Set this to be over 3. So 6 times 3 is 18, so negative 18/3 plus 16/3 leaves us with a net negative 2/3. So there is our vertex form, which means we have an axis of symmetry at x equals negative 4/3. We have our vertex at negative 4/3, comma, negative 2/3. What else did we need? Find the vertex and the focus. Oh, yes, the focus, right? Okay, we got to find our focal length. So let's switch to a new color here. Focal length is always 1 over 4a. What is our a in this case? Negative 3. So we get 1 over negative 12, negative 1/12. Don't be intimidated by the fractions. They're okay. So then our focus is at, this is a y equals negative, so it's a frowny parabola. Okay, so from the vertex, we're going to go down. So we'll keep the same x value as the vertex, negative 4/3. I'm going to take negative 2/3 and add 1/12. Okay, so 2/3 is how many twelfths? 2/3 minus 1/12, so this times 4. 2 times 4 is 8. Minus 8 minus 1, negative 9/12. Hey, that reduces. And we get back to divide both by 3. Negative 3/4. Oh, look at that. That's neat. 4/3, 3/4. It's like reciprocals of each other. That's cool. I like this one. All right, look at that. So we got our focus. We've got our directrix. Will then be a line over here. So the directrix would be, oops, not a point. It's an equation. Y equals, in this case, instead of minus 1/12. We have to add 1/12. So this is, I said times 4, should be 12. So this would be a negative 8/12 plus 1/12, which gets us down to negative 7/12. That does not reduce. So that's the equation of our directrix right there. What else can we do? Direction of opening, down. Right, because A was negative. That was easy. And then length of the lattice rectum and a quick sketch. Okay, length of the lattice rectum is 4 times the focal length. So we'll take this guy right here. Running out of colors and space. A little bit darker green. So the lattice rectum equals 4 times negative 1/12. Or you can remember it's just 1 over A, whichever works for you. So 4 times 1/12 gives us negative 1/3. And now let's create a sketch. So I'll give myself a set of axes here. We need a vertex, which is at negative, comma, negative. I'm going to put it right there. I get to scale my axes however I want. So if I say those are negative 4/3 and negative 2/3, then they are. Right? We can just tick off every negative 2/3 here, right? This is, we'll just scale our graphs in thirds. Okay, the focus is then at that, but even lower. So 3/4, a little bit lower there. Directrix, a little bit less so. So we've got that line going here. And the vertex itself passes something like that. Probably made it a little too steep. It's a little bit wider than that. Okay. You can tell because the lattice rectum should be 4 times this distance. So we have that distance, 1, 2, 3, 4, right? You can use that as your little scale. Just like how before we would always create, right, 3 points. Use your lattice rectum to help you build those points 2 and 3 that should be on your parabola, and then you just connect the dots with that curve. Or if you're creating the scale yourself, put them in there and retroactively say what the dots should be. It's your sketch. All right, how's that? Full and complete example. You ready for the quiz now?
Maybe.
Maybe? All right, let's say yes. It's a quiz. You can retake it as many times as you need. The retake code will be up after school and available for the rest of the week. So remember, this covers all 3 sections that you read about. You are now best equipped to deal with the parabola bits. So I expect a solid at least 1/3, 33% on here. So go to joinmyquiz.com, enter the code 887889. And when we get started, you'll have about 15 minutes to do what you can in class. Joinmyquiz.com, 887889. Pop, 2 at a time. 3, 4. All right, let's begin. Nice cozy holiday trapping. Remember, you can, of course, use your notes. Try to pick questions that aren't too computationally heavy and more reading-based. This will give you a little preview of what else we'll be dealing with the rest of the week. Class. I'm going to wrap up the YouTube video here. Quick reminder then, for the worksheet is your homework tonight, due tomorrow. The different levels are listed there on Classroom as far as which questions on the worksheet you need to answer.